Hi guys, this is Dr. Aeronautics, and we're sitting in a Delta glider on the ground at Cape Canaveral for our next tutorial, which is two checklists. Checklist 1, ground cockpit startup, and checklist 3, ground takeoff, is viewed on the checklist menu. We have the spacecraft totally off, and we're going to go through all of the checklists with a little bit of modification, as I told you in the last episode. If you did not watch the tutorial on the panel overview, you should watch it now, because there is so much to talk about. I can't really spend time on where stuff is. That was the whole point of the last episode. Also to note, unfortunately, the double subways video will not be coming out because well, thanks to the brand of my processor, it sucks. So when I try and record, the frame rate goes from 300 to 3 FPS. And, well, it's a series of pictures at that point. So we're going to have to forget that. Meanwhile, we're going to go ahead and begin with the ground cockpit startup. And again, I will be changing the order of a few things to better suit realism. The idea is don't turn something on until you need it. So we're going to begin in checklist 1, which is a ground cockpit startup. So the first thing we need to do is turn the EPU on, which is found up here. That is already on. And to buffer it up, we're going to go ahead and turn the battery on to give us maximum starting voltage. The next thing we have to do is start the auxiliary power unit, which is the power source of the spacecraft. So we're going to go ahead and initiate the APU auto start sequence. Okay, so we see here in the system event message logger that the APU is started with all parameters nominal. Apologies. So we're going to go ahead and turn the generators 1 and 2 on. And both of them are good. Now it says to select generator 1 or 2, but I don't like to do that. I like keeping it on EPU both, because that way if you lose a generator, you still have power. If you, so if I put it on generator 2 and we lost 1, well, then we'd basically lose our, oh wait, no, I did it backwards. If I put it on generator 2, and generator 1 was fine, but we lost 2, well, now we've just lost power. So this is why I do both, is because if you go to this one, and now we kill 2, we still can run on 1. So that's why I leave that on. So I'm bypassing that step. Now it says to turn all power on. This is the biggest one that I disagree on. You don't need the HUD and the MFD on until you're going to take off. So as a result, we're going to start in the order that I have explained in the other tutorial. Oh geez, something's wrong with me. I did that last episode too. So we're going to turn the life pack on, but it's not being used right now because we have 2 doors open. And now we're going to begin by booting the main computer. So also to note, I have scouted out line 5 on Norsden Lantiniso. It looks pretty interesting. Mostly goes through forested hillsides and arrives at a dry tundra in the north of Norsden Land. I've also opened up the final 2 maps of Norsden Land, so I can now plot it, and I'm going to take care of it. We currently have enough iron to make 2,000 rails, so I'm going to go ahead and do that, and then lay the track down, and then we'll be ready to go from then on. Okay, so the computer has booted. Now we're going to, we'll continue down the line. We can go ahead and turn our main bus on to get power to all of our systems. Turn our engine power on, and you can see here this will now illuminate. And Well, I guess the airlock now would be the final thing. Radio, MFD, and HUD stay off for the time being. There's no need for them. So we're going to turn the EPU off now. We don't need it as we've started the APU. The next thing to do is to begin closing the airlock doors. So I've begun doing that, and you can kind of see the airlock doors here closing. Okay, we can close the outer door now. Okay, and now the nose cone. So you'll note that the checklist hasn't told you to turn on the oxygen yet. But if I didn't open up, it's nice how quickly that does. If I didn't open up this canopy, we'd now be sealed away from the atmosphere, and we would be running out of oxygen and quickly filling the cabin with carbon dioxide. So that's why I go ahead and open up the canopy before a flight, is because we can still let the air get in through the top. Okay. Now we're going to turn our gear hydraulic pressure on. So we're going to take off soon. That means we have to be very careful that we don't accidentally raise the landing gear. Next is to fasten seatbelts and turn the strobe light on. So fasten seatbelts basically means that you wear your spacecraft. So if you look here, these guys aren't wearing their spacesuits. Did I say wear your spacecraft? I meant wear your spacesuit. You turn the seatbelt on, and they're now wearing vacuum suits. Okay, so next is the strobe light. So it's simply a strobe light and a beacon here. I turn it off when in orbit because well, it's useless because it's just a light, and you're in space. You don't need a light when you're in space. Because by the time you're moving 17,000 miles per hour, so by the time you see it, if you're going to crash into it, you would have already. Okay. Where are we? Ah, yes, the middle panel. So we're going to go ahead and change the gimbal mode to comp auto. And now the lower panel, we're going to check the fuel. I don't like that. It's not fuel or full, and we're going to ascend to orbit. So I'm going to open the fuel hatch and turn the volume down so that the noisy, nasty truck doesn't hurt your ears. Okay, noisy, nasty truck has arrived, which means we can open the fuel hatch and open the fuel valve to main, the filling drain. Actually, it's the fill, because the drain will be here. And we're full, so we're going to go ahead and turn it off, disconnect, and close the external fuel hatch. Tell the big nasty truck to go away. Okay, fuel has been checked, so now we basically turn our valves on, turn our hover valve, and I know this is a little bit redundant, but we turn them on anyway at the start of flight. I can't exactly explain why I like turning them on, because we never use them, but I do anyway. So we go ahead and turn this on, this auto air intake, which basically oxidizes the fuel, so we can kind of use them kind of like turbofan engines, although it doesn't seem to work that well, and also get a little bit of external oxygen as well. Main valves, obviously, and the reaction control system valve 2 we went on as well. We went to give a check that fuel dumps and cross speed are off, which they are. And now we move over to the life support panel. So we're going to go ahead and make sure that the input valve pressures are off. They are. And then the selector switch is set to off. And now we're going to go ahead and switch A and B systems to auto. So this is for redundancy. So as soon as there is an external door closed, it will go ahead and activate. And now for, again, safety redundancy, I mean, this is a life support system, so it's incredibly important to us. We're going to turn both the main and backup recycling buttons on. And now it says ready for takeoff, so we can go ahead and move to checklist 3, which is the next part of this tutorial, which is a ground takeoff and ascent to orbit. So next step is the APU is off, but we need to turn the battery off. So there, now it's off. We have 0 start bus voltage, which is okay. Check to make sure the seat belt is on, which it is. And now we're going to go ahead and arm the ejection seats, which I demonstrated last tutorial. Okay, so now if we want to eject, we can. And Windows Ray filter, again, I've explained that. We're going to go ahead and set it to medium, because we are going into space. And now we need to turn the ship control on atmospheric auto. There's no APU for the hydraulic pressure, so as long as the APU is on, we have hydraulic pressure. So we can go ahead and turn it on atmospheric auto right now.
Pitch elevon, translation, rotation, atmospheric auto.
Good, so now we have air flight control surfaces that will automatically transition to RCS when it's time. And now we are ready for the final stages of checklist. So, I really ignore this. This isn't really a checklist, this is more of a procedure. I, for the most part, ignore this. The next thing we have to do is close our cabin hatch. So this is going to go ahead and close now, and when it closes, you'll see the life support system start flowing. Okay, there it goes. So we're maintaining everything except for contaminant and CO2 level. Those will slowly rise to about 0.0002 parts per million and about 600 parts per million CO2, if I remember correctly. We're almost done now. So now we can go ahead and turn our radios on. And our MFD. We're now at the final stage, so we're going to turn this one to the map. Good. And we're going to take this one to surface. And that is why I wait till the last minute to turn radio on, is because it does that, and it gets relatively annoying until you get far away from the Earth. We'll go ahead and turn it off later if it squawks too much. HUD power now, and we have a secondary HUD again. Turn that to atmospheric. That would be ascent, re-entry, and that would be orbit. So 3 is the one we want. And I believe we are all set. So now what we're going to do is check that all doors have closed and we're ready for takeoff. So we hit D for the computer, and then we check vessel state damage, 6, and we want to be for takeoff checklist. So 1.
Configuration correct.
Okay, so we're actually ready for takeoff right now. So I'm going to go ahead and reset the computer to display 3 for temperatures, because I always like to keep an eye on temperatures whenever I'm in the atmosphere. And now I'm going to basically explain what's going to happen from here on out, because things will move very fast now that we are ready for takeoff. Basically what we're going to do is taxi to the runway, then we're going to apply full power, rotate when it says to, maintain 10 degrees, And then when we have a positive rate, I put the gear up. Shortly after takeoff...
We're running a little bit above our nominal water predicts. How are we doing on our cryo usage? Okay, great, thanks.
That didn't even make sense. How are we doing? Okay, great, thanks. What? It's really annoying. I'm going to just turn it off now. It's just really annoying. Gear up when we have positive rate, and then we lock the hydraulic pressure for the gear after takeoff. And then at 10,000 feet, I activate the turbo pump, which is kind of like the Delta Glider 4's version of the XR2 scramjet to make up for it. And that allows us to get an extra boost and thrust up to orbit, and then we MECO and then go through the everything else here. Now, we could do an ascent autopilot. So there's two autopilots here. One for the ISS, one for Mir. It will put you in the most fuel-efficient ascent to the space stations. And if we go to the program shortcut settings, we see that there is another one for Earth Ascent, which is not related to the one for ISS or for Mir. This will just simply move you straight out. I believe you can actually set azimuth in here. I'm going to go ahead and select it. Now, unfortunately, what happens is when you select it, it activates as well. So I have to very quickly stop it from happening by hitting the space bar to deload it. So we're going to Alt-6 to load it and deactivate it. So it says heading here, so we can actually adjust the azimuth here using numpad 1 and 6. It doesn't want to work for some reason, though. Are you sure? That's... am I reading that? Numpad 4 to 6 for heading correction. That's really weird. It doesn't want to work. But it looks like it could be if it works. Oh, speed... Oh, maybe that's because I have to be faster. Speed greater than 500 for it to work. Well, whatever. So, we're going to go ahead and go here. And we are all set for takeoff now. So we're not where we want to be right now. So we're actually going to go ahead and load the... We go to 1 for program display, clear it out, and now we're going to Pro 400 Spec 0, and that is the taxi speed autopilot. So we're going to hold this speed and taxi to the runway threshold. Executing.
Hold speed autopilot engaged.
Sorry, buddy, we're going to run you down. Okay, right there is good. We're just going to drift to a stop here. Alright. And one of the annoying things about the XR2, the Delta Glider 4, I'm not sure why I haven't deactivated it yet. There is, oh, good thing I caught this. There is a problem with it, and that is when you accelerate, your head goes up, and then the HUD disappears and you can't use it, which is really irritating. And I don't like using glass cockpit. It might even happen in there. But either way, we're ready for takeoff now. So we're going to clear the program out and go back to the temperature displays. And we're ready to apply full power. Okay, first ascent with the Delta Glider 4 tutorials. Counting down from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Full power of the Mark 4 engine.
80. V1. Rotate.
Okay, so we've reached VR. We're rotating. We have positive rate. Putting the gear up and throttling back. We're not aiming for anything in particular, but we're going to go ahead and turn east for the time being, because most orbits that we do are low inclination. Okay, that should be good enough. We're going to begin trimming now. There we go. And now we lock the gear hydraulic pressure and go to full power, pitch up to 30 degrees. There's 10,000 feet. We're going to go ahead and activate the turbo pump now. Turbo pump's activated. You can see the thing here, and we're under full power, straight up. $35,000 feet in altitude. We're going to go ahead and look through here. So we're here at the 1 in orbit section. Once we finish the ascent. These should be... Oh, okay. Basically what's going on here is this is explaining to us the total amount of thrust our engines can produce, which means as we go higher through the atmosphere, we'll gain thrust, and these should eventually turn yellow, indicating that they are, these usually go yellow-orange when we have our turbo pumps activated. We're doing all right with temperature here. Altitude is now 67,000 feet. I forgot to mention our automatic air intake opened. You can see here that the vents are opened. They're taking the air in and processing it for engine thrust. Unlike the XR2, the Delta Glider 4 does not have multiple temperature scales, so we're stuck with Celsius. The great news is, though, okay, we're starting to get a bit hot. The great thing is, unlike the XR2, the craft can simulate temperatures on I think more planets than the XR2 can. I forget whether or not it's accurate at the moon. But if you're looking for a real accurate temperature readout, the Aero Freighter. We won't see that until Norsden Land to NISO, far into the spacecraft or spaceflight future. And that will give you temperatures in deep space, which is really cool. So when you get close to the sun, It'll go up to about 800 centigrade. When you go really far out, it'll drop to about minus 260 C. Okay, did you see that? The beep. Flight control has switched to the RCS mode. We're now under 7 kilopascal dynamic pressure, which means it's activated the RCS, and now you can see the thrusters under there. We're using RCS thrusters to partially control the ship. Time we switch over to this, change the projection and altitude readouts. Okay, we're getting hot again. Okay, now we're getting very hot. Okay, this is becoming quite wasteful. There we go. I let the slip, or rather the slope, get away from me a little bit. So we're going to go ahead and trim up. So one of the things you'll note is that the Delta Glider 4 is a lot less powerful, and there you can see now the automatic air intake doors have closed again. You'll note that the XR, or the Delta Glider 4, is much less powerful when it comes to initial getting to orbit, because we're using the Mark IV engine. So you'll find it takes a lot longer than the XR2 to get into orbit. You'll also notice that these engines are gold colored. That's because of the turbo pump. When we disengage the turbo pump, we'll go ahead and go blue. We're just over halfway to orbit now. Also notice that the handling of the Delta Glider 4 in an atmosphere is not as smooth and lift efficient as the XR2. This is why I prefer to fly the XR2 in atmospheres and the Delta Glider 4 in vacuum. Could you believe it? The first time that goes off and I'm in flight, I actually don't immediately think that it's this, which is rather weird. So, another thing to note, remember I've set max fuel to short range, which is only low Earth orbit. That means the furthest I can get is the International Space Station. So we're going to be almost out of fuel by the time we get into orbit. In addition, the maximum oxygen reserve is 1 week. So with 3 crew members, that only means about 10 days. Yeah, 10 days, 14 hours. Okay, at 7,000 meters per second, I deactivate the turbo pump because we don't need as much thrust to stay aloft. So I'm going to deactivate the turbo pump now. And now you can see the engine exhaust plumes are blue. There's 300 kilometers, so main engine cutoff. So we only have 36% fuel left, but again, this is the most conservative fuel setting that you can possibly have. Only short range, low Earth orbit. So this is the lowest ceiling of use for the Delta Glider 4. There's a lot more that you can do with this than just reach orbit. We want to look at the total G meter because we are actually decelerating, and I'm going to go ahead and do another burn because I don't like that we're perturbing this much. So just continue burning until we get out to about 345. And hopefully that won't deter too much. You can see the temperatures are dropping now. It's about minus 79 Celsius outside. So you'll notice that there's no primary HUD buttons here. So the way you have to go about navigating this is either by the key commands or by the buttons. So I'm going to do both actually. So I'm going to tell it to change the HUD here, and with the key command to change the color. And now this is the stage what I talked about that I would be doing to program the spacecraft. So the command is Pro 200 Spec 1. Oh, whoops. Wrong button. Pro 200 Spec 1, which is the prograde autopilot. E to execute. And now we're turning prograde. Okay, we're finished the ascent. So now we go to orbit. And now you can see this one gives a readout of... Actually, I haven't told you about this. So this gives an altitude readout in feet and miles, and then in knots, in miles per hour, a Mach number, the mass of the vessel. Then it gives another mass of the vessel in this one, landing gear and speed brake information, the G meter or accelerometer, absolute, the range of the orbit, if there is one, the glide slope, the heading, the bank, pitch and angle of attack, and now this is the orbit one. That looks like, is that Jupiter or Saturn? I don't know. It's Saturn. Okay. Speed in kilometers per hour, again, Mach number. This actually gives you orbital elements, though. It gives you the eccentricity value, the apogee and perigee, distance in kilometers, which would be altitude, and you'll note that with these three values, we can actually find the semi-major axis with a little bit of math. And then over here is the inclination of our orbit, 45 degrees. That's relatively high. That's probably 40 degrees ecliptic and not equatorial. Yeah, that looks more like it. So, okay. So yeah, that's an ecliptic inclination, which hopefully you can modify using the Ascent autopilot. And then, it gives heading, which is really not important. Vertical speed, which is useful for re-entry. A dynamic pressure readout in kilopascal. Right now we're reading 3 Pascal. So now we can continue with the checklist. So when in orbit, we're in orbit now. Cabin recycling backup system buttons off. Now that we're in orbit, we're safe to some degree, so we can go ahead and disable our backup system to save fuel. Power. Next, we deploy the radiator by the use of this button here. So I'm going to go ahead and turn the craft around so that you can see the radiator opening up. And just wait for confirmation. Okay, radiator fully deployed. So we're all set. I did not know it could do that. Okay, and we'll go ahead and return the autopilot to its... As I said, I can be very quick with these autopilots when I want to be. So the outside air temperature right now is about minus 133 C. That's just a little bit cold when it comes to the vacuum of space. Okay. Radiator has been deployed. So there's 2 more steps. It doesn't actually mention it. But before we turn the passenger seatbelt off, we should safe the ejection seats because they're useless now that we're in orbit. And now that they have been safed, we can turn off the seatbelt. So they've taken their spacesuits on, and now they can move about the cabin and do all that other kind of weird stuff that airplane people do. I say that too much. So now, this completes the second checklist. Now I can also explain what I would do if I was going into a higher orbit or a long haul or a long stay in low Earth orbit. So if I was going to stay a long time in low Earth orbit, I might change the thing from atmospheric auto, the control mode from atmospheric auto to rotation, because I won't need it. If I go up into a higher orbit, I'll turn the strobe off. And if I go really far out, I'll even turn these tanks off just to conserve power. And the other thing I do, if I go into a higher orbit, would turn the filter to high, and then once I get out of the inner solar system, back to medium again. So, this pretty much just about completes this tutorial. We've done checklist 1 and 3. Maybe we'll do checklist 4 and 2 next time. Actually, we'd probably do 4, 9, and 2 next time. And this is the Canary Islands, I think. They might be a little bit further north. But the map says... No, actually, I think those are the Canaries. These are... I forget the name of these islands. But that's basically it. We're in a stable orbit configuration now, and now we can do whatever we want to. Dock with the ISS, mirror, go to a higher orbit, perform orbit operations, and other things as well. So we now have our beautiful spacecraft in orbit. And this is Dr. Aeronautics saying, I will see you guys next time for the next tutorial. And interesting, should Mars and Mercury be next to each other? Because I can tell that this one is orange and this one is red, meaning Mercury is on top and Mars on the bottom. And I was completely wrong. How did I mess that one up? Seriously. Zoom, zoom, zoom. We're going to bring the field of view down as far as we can. And this really irritates me because I have good color recognition. See, now why does this one appear more red than that one? I don't understand that. And this is Mercury. I don't understand why that's Mercury. I've never made a mistake this stupid before in guessing in planet hunting. Oh look, Venus is just now setting on over behind the Earth. Here we go. It's being occultated or oculated, one of the two. So I will see you guys next time. Bye.